All right, guys. So several important things. You received my email over the weekend, correct? Do you understand that you have to hurry up and listen to those lectures? So I'm going to try to cover as much as we can, and we can go overtime. We will probably take reading day and use that to finish the material to the extent possible. But you should go over those lectures, and you should spend a lot of time preparing for the final exam. It may be hard. All right. Without further ado, guys, let's see who is here. 25 people. Yes, Christina? So for the preparation of the final exam, my suggestion is twofold. First, I gave a review last semester for the final exam of many hours. You can look into the videos from last semester. That's one. Second, this Sunday, I will try to give you an optional review in case you want to join. So Sunday around 1:30, 2 o'clock, I plan to have a review for the final, or at least part of it. Good? How many of you would like to join on Sunday around 2 o'clock? All right, so I'll send a message, guys. Anticipate that it will be around 1:30, 2 o'clock. Good? We will go through the material. We'll see how. But okay, guys. So first, you received my message. I mentioned in case there would be need for extra credit, something like, let's say, completely out of the blue, you had no time, whatever. I will see how many of you are putting the least amount of effort. It means in the next few classes, right, be sure that you are here and that you are on my list, because if not, then there will not be any consideration, any extra credit, nothing. We can talk about the test soon. I am still to grade it. You will probably get it much later. It will take me a while. It will take me at least a week to grade your exam. You can look at the practice exam on the internet. We can, if you want to talk about after class, we can talk about some questions, but preferably not this class, next. Okay, are you ready? We're going to go fast, and hopefully you manage it. Let's go. I don't know. Okay, guys, so what you have to do now, this topic is called antiderivatives, and it's a very, very simple topic, in fact. Imagine you come late to class, and you know that feeling. And when you come late to class, you see the solution to the question, but not the question. What was the question? If the derivative happened to be, let's say, something like this, guys, you see? So the derivative happened to be 2x. If the derivative happened to be 2x, you know that the original function, you can guess it, might have been x squared, or might have been x squared plus 5, or x squared minus 7, and in general might have been some x squared plus a constant. You cannot retrieve from this information alone what was the constant. Do you agree? Now, very quickly, guys, and I need you to be really quick. For a, imagine that the derivative happened to be 7. What was the original function that we tried to differentiate? 7. To the best of your ability and quickly, 7x. But to be precise, guys, 7x plus a constant, right? Maybe it was 7x plus 7 or 7x minus 12. Agreed? So 7x plus c is the best possible guess you can offer. The derivative is 3x squared. What's the best possible guess you can offer? X cubed plus c. Brilliant. Okay, the derivative, and now, guys, you see, so it's x cubed plus c. Now it gets a tiny bit more complicated. The derivative is x squared. Can you tell me what was the original function if the derivative was x squared? Going once, going twice, going third. Okay, fast. 1/3 x cubed, exactly. Now, how do you guess it, guys? You see, here is how I suggest. You see, you know that the power rule drops the number and reduces it by 1, right? So if it were x cubed, then taking the derivative will make it x squared. But the 3, the power will come down. Something has to greet it to cancel it out. So it must be 1/3. You agree? Do you understand how I reason? I can go very quickly back and forth. I can say, okay, x squared, x cubed. X cubed, it's 3x squared. So there must be a 1/3 to greet the 3 that drops down to cancel it out. Everybody understands? Beautiful. So the answer is 1/3 x cubed plus c. That's the best guess. For D, please. X to the 5. What's the best guess you can come up with? X to the 5. Come on, guys, you can do it. Well, very good. You guess x to the power of 6, but then you greet it with 1/6. You agree? And then plus a constant. Then in general, if the derivative is x to the power of n, your guess is x to the n plus 1, and you multiply by 1/n+1. Do you see why? That's because you want the n plus 1 to come down and be cancelled. Good. Now the derivative is e to the x. That's very easy. The function itself had to be e to the x plus c. Yes? Now, guys, it gets a tiny bit more difficult. The derivative is e to the power of 5. What is the original function, please? Yes. It is a constant, it's just a number. So that means that if the derivative is not dependent on x, guys, that must mean that, that everywhere the slope is the same, which means we're dealing with a line, which means that line is e to the 5x plus c, because the slope multiplied by x plus c will give you an equation of a line. Any line can be written as a number multiplied by x plus a constant. You agree? Any line is like this. That's the, what do you call it, slope-intercept form for lines. So it is e to the 5x plus c, understood? So anywhere in the derivative when you do not see an x, that means that all the slopes are aligned. It means you're looking at microscopic line segments that are all adjusted in a line. Interesting. And the derivative of a function is 1/x, guys. What must have been the function? Very good, Christina. You are a sharpshooter, or you're a fast drawer, right? Excellent. The answer is, of course, ln. But the nicest answer is absolute value of ln. Do you remember why, guys? 1/x can be defined for both positive and negative x. ln of x is only defined for the positive x, but ln of absolute value of x, we mentioned that before. The derivative is 1/x globally, right? So the antiderivative of 1/x is ln of absolute value of x. And so we have ln of absolute value of x plus c is our answer. Good. Now the derivative is for c, guys, x squared plus 5x plus e to the x. Please, as fast as possible, type what is the solution. What's the question? Sorry, the solution is here. What was the problem? All right, Joseph, good. Good. Very fast, guys. We know that derivative of sum is sum of derivatives, yes? So all we have to look at is, we just take them one by one. X squared, then original should have been x cubed times 1/3. 5x. Oh, well, I mean, if I just have something like 5/2x squared, that should work. And e to the x, and of course, plus a constant. Because constant, I mean, I cannot figure it out. Yes? So there is a plus a constant here that might be useful to place. Good. Now, guys, go ahead and solve D. The derivative is cosine. What must have been the original function? Very good. Sine x, of course. So the original function must have been sine x. Because we know derivative of sine is cosine. You think in reverse. Now, guys, derivative is sine. Can you guess what was the original function? Derivative is sine. Very good. You see, you guess, okay, well, I know that cosine, if you take the derivative, will produce a minus sign. So you see, I reason like this. Cosine produces, when you take derivative, minus sine x. So then I place a minus, and the minus would be here, and that works. You understand? So I very rapidly take a guess and correct my guess when it's not exactly correct. When there is a small mistake, I correct it. My brother, he has a way. What I mean, you mean a way to remember it? Yes. Now, guys, next question is f, please. F prime is secant squared. What was the original function, please? What produced secant squared? Very good. Tangent. Tangent plus c. Yes. Derivative is secant tangent. What is the original function? Very good and very fast. I like it. Secant x plus c. Derivative of secant is secant tangent. Derivative is cotangent squared. What is the original function? Derivative is cotangent squared. Can you guess the original function, guys? Very good. Except what? Except not cosecant, but minus cosecant plus c. Because derivative of cosecant is minus cotangent squared. Yes, guys, and that happens simply because we remember the functions, you see? If you remember the functions and their derivatives, you can quickly guess what they came from. And of course, here is another one. Derivative is the cube root of x squared plus x square root of x. Can you figure this one out? What was the original function? All right, let's do it together then. First, guys, look at it. What is this expression? This is x to the 2/3, and this is x to the 3/2. Do you agree? It's much simpler in this form. Now, I know what function could have produced 2/3, right? So I just take x to the power of, I just add 1. 2/3 plus 1 is 5/3, correct? This is 5/3, and here I write 3/5 to cancel it. You see, because 5/3 drops down, 3/5 has to cancel it. Plus, here it's 3/2, so I have to have x 3 plus 2 here, right? Would be 5, but this time 5/2. So here I have 2/5 plus a constant. Understood? Good. It's just x to different powers, and we know how to deal with that. We know that in reversing the derivative, we just add 1 to the power and divide by the reciprocal of the power. Okay, guys? Very good. Hopefully that's natural. Now here is another one, guys. 3 to the power of t to the 4 is the derivative. It's 3 to the power of t to the 4 minus 3 cubed plus 60 squared divided by t to the 4. This is our derivative. Can you tell me what was the original function, please? Or at least what should I do to obtain it? Quotient rule is the derivative, but I need to figure out where it came from. Okay, and so what are we going to do, guys? Let's look at it a bit more carefully. So instead of dealing with the problem as written, why not divide the t to the 4 everywhere? Look at it. I divide t to the 4 everywhere, so into here, here, and here, and I get 3 minus 1 over t plus 6, 1 over t squared. Do you agree? And this is the same as 3 minus 1 over t plus 6 to the power times t to the power of minus 2. So what do we get here? This becomes 3t. 1 over t, the antiderivative is ln of absolute value t. And the antiderivative of 6t to the minus 2 is minus 6 to the t to the minus 1 plus c. Do you see what I did? Right, reversing the quotient rule. Maybe it came from quotient rule, but then I have to recognize that it looks like a quotient rule. Just because I see a quotient, it can be complicated. Okay, in general, guessing backwards is much more complicated than moving forwards. Right, you need to be kind of good. It's usually much more. It's much easier to walk forwards than to walk backwards. You agree? Yes, that's the answer. It takes a few moments. Just distribute the t to the 4, and here is what you get. And then that's not very difficult to anti-differentiate. Here is some more, guys. Derivative is 5x squared plus 2 to the power of x plus 1 over x. Tell me what was the original function, please. Well then, what's the original function, guys? Let's see. 5x squared, we easily can take the antiderivative of 5x squared. It's 5 over 3x cubed. Do you agree? Now, 2 to the x. What could produce 2 to the x? We know that the derivative of 2 to the x is 2 to the x ln of 2. Do you agree? So the next one to cancel it out must be 2 to the x divided by ln of 2. That's because I have to remember that the derivative, here is how I think of it. Derivative of 2 to the x is 2 to the x ln of 2. Do you agree? You should be able to obtain that formula. We spend so much time on it. So what does it mean? It means that if I take 2 to the x divided by ln of 2 and I take the derivative of that, what do I get? I get 2 to the x divided by ln of 2 times ln of 2, which is 2 to the x, just as I planned. Yes? So again, we have 5 over 3x cubed plus 2 to the x divided by ln 2. And then what's the antiderivative of 1 over x? It is plus ln absolute value x. Do you agree? Plus c. And the question is complete. So ln absolute value of x, because ln x is only the antiderivative when x is positive. But ln absolute value of x is the antiderivative for all x. If x is negative, positive, doesn't matter. Good, so that's more general. All right, what about this, guys? Do you recognize the derivative is 1 over root of 1 minus x squared, and the original function must have been? And the original function is, of course, sine inverse. Very good. The original function is sine inverse x. Good. For b, what is the original function? Tangent inverse. Very good. For d, do you recognize the original function? So it's of course plus c. Don't forget to add the c. For d, the original function is yeah, secant to the minus 1. Very good. Secant to the minus 1x. Cotangent would have the same thing but with a minus. 1 over 1 plus x squared but with a minus. Good. So this I will mention later, I hope, right? So very important, guys, that I am doing something that is contrary to my nature. I'm skipping a lot of theory. And the theory is pretty much everything. So we'll get back to it. Here is a preview of something you have to know, and that's called U substitution. And what is U substitution really, guys? It's reverse chain rule. You understand? When what you're doing when you integrate is reversing something. So U substitution is a technical device to try to help you figure out reversing chain rule. But I will teach you something that if you follow, it will do it much faster in most cases, right? You don't even need to carry the procedure. The mechanism, you right away see the answer. And let's try it. Okay, guys? So for instance, imagine that you see that the derivative is cosine of x squared times 2x. Do you see that in the belly you have the small fish and here is the filleted small fish, as I call it, right? X squared and its derivative, which means that the only thing I need to figure out is the antiderivative of the outer function. The antiderivative of the outer function is sine x. You can verify. Look at it. Derivative of sine x squared is cosine x squared times 2x. Do you understand? So how do you reverse chain rule, guys? Make sure that you follow me. Look at it. You locate the outermost function, right? And only need to figure out the antiderivative of the outermost function, and you know everything. Do you see why? That is true because look at it. This thing is just gonna jump back in, and then you just have to take the antiderivative of cosine. You're reversing the steps of chain rule. So in the chain rule, what do you have? You have the last step is derivative of the inner function, then the inner function, then the derivative of the outermost function is your first step. You understand? So when you reverse, you go in this order. So you have to end up with the original function here. Do you understand what I'm saying, guys? So you ignore everything else. You just have to recognize its chain rule, ignore it, and just take the antiderivative of the outermost function, and you're done. Let's see if we can understand what to do if it's slightly modified. Right, so in this case, the answer is sine x squared plus c. Now suppose that the derivative is cosine x squared times x. Do you see that it's not exactly chain rule? Do you agree? Because the derivative of the inner function is 2x, it's not x. So what do? I use wishful thinking. Look at it. You see, I see this is my inner function, and the derivative of the inner function is missing a 2. So I insert a 2 and I place 1/2. In other words, what I do is I complete it to make it look like it came from chain rule. Do you understand? And so what's the answer? The answer is 1/2 sine x squared, because now, look at it. Now I can ignore this function and its the inside function and its derivative, and I can focus on cosine. The antiderivative of cosine is still sine. So my answer then is 1/2 sine x squared plus c. Good? Now, guys, the way mathematically you ask for antiderivative instead of saying that the derivative of the function is equal to such and such formula, what's the function? You use it with the symbol. You use this symbol. This is an S, this is an elongated S, fx dx, and that means the function whose derivative is little fx. It means capital F and its derivative is little f, right? So for example, the integral of 3x squared is x cubed plus c. The integral of 5x squared plus e to the x is 5 over 3 x cubed plus e to the x plus c. So far you understand? The reason for the symbol is very important and very useful, but I will keep it for later. I will just focus on driving the calculations today in the next class, and then we will focus on theory on the reading day, which I'm gonna commandeer. Good? You understand, guys, how that's supposed to work? And of course, this means antiderivative of little f and little g. That is just the antiderivative of little f plus the antiderivative of little g. And of course, constant times f, I just need to figure out the antiderivative of f. Do you understand why? Because the antiderivative, because basically derivative of a constant times a function is simply the constant times the derivative of the function, right? It's precisely talking about reversing those processes. All right, guys, let's try to figure this thing out. It's a bit difficult, but what might have happened here? Look at it, right? So question number A, we have x squared root of x cubed plus 1. Yes? So when you train your eye, you recognize what might have been happening here. Do you see there is a 2 and there is a 3 here? That means what happened here is chain rule. You see, because x cubed plus 1, its derivative is essentially x squared. Do you agree? What is missing here? What would you, how would you complete it, guys? This is not exactly correct, not exactly chain rule, right? So here is what's happening. Do you see this? Integral root x cubed plus 1 times x squared dx. What do you think is missing here to make it perfect chain rule? Let me give you again a hint. Exactly, 3x squared, Joseph, you nailed it. Do you see? Look at it, guys. Look what happens here. I'm just, my eyes, once they're trained, they look at this. So I think inner function. And here I think it's derivative. Yeah? So what is missing, guys, is a 3. Do you agree? For this to be true, I'm missing a 3. And I put it, now it's perfect chain rule, but I never had a 3, do you agree? So what I do is I multiply by 1/3, because 3 and 1/3, they cancel each other out. You follow what I do? By wishful thinking, I make it look like it is just exactly chain rule. And so what is what's my answer now? You see that this is a root function. What's the antiderivative of root? Root is the same as 1/2. You agree? What's the antiderivative of a root? Well, it is 3/2, whatever is inside, 2/3 plus c. And then what's inside? Inside is x cubed plus 1, and I'm done. Did you understand what happened, guys? Or do I need to go again through it? Do you see what I was able to observe? It's chain rule. Do you agree now? Chain rule. Why do it is a chain rule? Because my eyes scan it, I see root x cubed plus 1, and then I see it's multiplied by x squared. No, if I put a 3 here, that's the derivative of the inner function. Right, root inner function derivative of inner function. When I see inner function derivative of inner function, that's chain rule. So then I need to focus on only taking the antiderivative of the outermost function of the root. Right, because I'm reversing, I'm going in reverse. Remember how you take chain rule: derivative of outer function inside times derivative of inside. Yes. So if you go in reverse, you complete the antidifferentiation. If you go from there, what happens? The derivative of the inner function, imagine rewinding. So the derivative of the outer function, it kind of jumps in and disappears and becomes the inner function. And then I am left with the derivative of the outer function. And then I just reverse that. Can you see that in reverse, guys? Can you imagine me solving chain rule and you play it backwards. So if you play it backwards, the inner function kind of jumps out, disappears, and you have the derivative of the outer function with the inner function undifferentiated. And then when you jump back, the derivative of the outer function disappears. So here I realize I just need to eliminate the derivative of the outer function. Are you with me? I just need to eliminate, the derivative is root. And root is power 1/2. And what has produced power 1/2 if I differentiate it? It must have been power 3/2 because I subtract 1 from the power. And the 3/2 would have dropped down. So to cancel it, I need to multiply by 2/3. Do you agree? Let's do another one. Your turn, guys. Can you figure out in B? Look at it carefully, guys. B, cosine cubed theta, sine theta. What is the answer then? Well, the cube, careful, Francis, almost, but you're mixing up the powers here. All right, let's do it together. Are you ready, guys? Look what's happening here. So this is integral, and I'll write it like this: cosine to the power 3 sine x. Yes? Would you like to make any changes, please? I mean, I used theta, let me keep theta. Would you like to make any changes to this expression so that antidifferentiation is easy? Very good, Christina. Guys, do you understand how all of it works? You need to recognize that what you're dealing with is chain rule. It looks like chain rule. If you don't see it looks like chain rule, then of course there's nothing I can do. Right? You have to realize it looks like chain rule. Why? Because it happens that sine is the derivative of cosine. If I had a tangent here, it would be much more difficult. Do you agree? If I had a different function, it doesn't look like chain rule. Oops, I am not sure what to do. And most antiderivatives cannot be calculated analytically. You cannot have a simple formula for them, even if they exist. But here is sine. So what do? I say, I don't like sine. I like this. Yes, why do I like minus sine? Is because now it's perfect chain rule. Derivative of cosine is minus sine. But if I place something in here, I multiply it by -1, I can multiply by -1 on the outside. You understand? Now, in reversing it, guys, what happens? In reversing chain rule, right? The last thing to be reversed is the power 3. So that would be cosine to the power 4 of theta times 1/4. There is the minus, and I'm done. Plus c. Do you understand how I do it, guys? Let me maybe show you in slow motion what I'm thinking about, right? So if I have f and g x and I take the derivative, what I will see f prime gx times g prime x, yes? So I take the derivative of outer function, keep inside, derivative of the outer function. So when I go in reverse, what will I begin seeing? If I rewind my writing it, I see f prime g of x, yes? So look at it, guys. You see it's already g prime disappears. It just we have g of x, and then the next step, I see f. So that means that all I have to do to reverse chain rule is figure out the antiderivative of the outermost function. Yes, only the last step is challenging in the list. You understand? Well, let's hope you do, guys. You see, if you do it my way, it's much faster. So C, e to the x cosine e to the x, I want you to tell me the antiderivative as fast as you can. So this integral thing means find the antiderivative of this function. What is it? I want to see it very fast. And many answers. Don't forget the plus C, guys. All right, very good. So do you see that for this case, it's perfect chain rule. You see, it's just written in another form. You see, guys, you have to recognize that the derivative of inner function I can write in front or in the back or afterwards, right? So this is what is C? C is the integral of cosine of e to the x times e to the x dx. Now all I have to do is reverse cosine, so that's sine e to the x plus c. Agreed? It's already in chain rule form. All right, guys, the last one may be slightly more difficult for you to see. Let's see if you can. D. Can you tell me what's the antiderivative for D? As quickly as possible, please. Very good, Christiana. Fastest drawer on the West, I guess, huh? Very good, Anna. All right, guys, so what do you do here? It's a matter of being able to look at the expression. Guys, look at it. Z cubed plus 1 and Z squared, right? You should see 3, 2, you should right away associate those things, right? 2 must be the inner function then, right? So what we have is Z cubed plus 1, if I put a 1 here, times Z squared dz. Do you agree? I can write it like that. Now, so then what do I think is the inner function? I think this is the inner function and this is its derivative. Do you agree? Now, this is not quite right. It needs a 3 here. So then I write 1/3 here. Next is, then I just write 1/3. This is now 1 over something. The antiderivative of 1 over something is ln absolute value of that something. We're done. It wasn't too difficult. You understood what we did, guys? We made it look like chain rule. There was a 3 locking. So this is what you do when you call U substitution, but they teach it, and I'll show you later on, that they teach it using change of symbols. So just to make it mechanical. I want you to understand it without wasting time on symbols. In most cases, it's not useful. Just right away, whoop, and you have it. Okay. It's theoretically useful, and it's useful in some cases, but not for those problems. You can do them faster. All right, so we are done with this particular part, guys. But now here is your next task, guys. It's another way to teach you how that works. Place something in the box to make the computation very simple, and I don't want 0 or 1, right? So other than 0, I mean, you can place 1 if you want to, but no 0 and not, well, see what you can create. I don't want a 0 there. I want you to place a number or a function that will make the antiderivative very easy. Yes, so place the number and solve it, but tell me more importantly, what do you place there? I'm trying to show you how such problems are created. All right, very nice, guys. You see this? It looks like it would be a nice chain rule. So I would really like to see here 3x squared. You agree? So if I now saw here 3x squared, the antiderivative would be what, please? Very good. Minus cosine x cubed. Very nice. Minus cosine x cubed plus a constant. Do you agree? Everybody sees the idea, guys. Now, could you repeat the same process for b, please? What would you have liked to see here? Very good. You want to see 1 over 1 plus x squared. And that will be what? If you do see 1 over 1 plus x squared, you will get what, please? Very good. Then you get e to the tangent inverse x plus c. Understood? So that's just a reverse chain rule. That's the idea. So you see, guys, this question can be written in a scary form, but don't get scared. It might have been written like this. Always search for the pattern. You understand, guys? If you see, you should recognize a function and its derivative, and do that fast. Good. Let's move on. So again, guys, there is area under the curve. There are those things that I am skipping for now, and I'm doing the calculations, but I am doing it with a very painful heart. So here is, guys, so here is, first of all, the definite integral. I'll get there later. Okay, guys, so when you see, you can see this s without numbers, and you can see the s with numbers, okay? So this is the process that you carry when you see the integral with numbers, okay? This is supposed to signify area under the curve, and if we pass this computation fast enough, I'll have time to explain the Riemann sums and everything else why that appears. Okay, so what you do here is you guess any antiderivative. So for example, 3x squared, any antiderivative would work. So x cubed is 1. And you write a line where you have 2 and 0. And so you do 2 cubed minus 0 cubed. And the answer is 8. Okay, so for instance, x cubed minus 2x. What do you do in this case? You'll just simply say, the antiderivative of x cubed minus 2x is x to the power of 4 times 1/4 minus x squared, and this entire thing I evaluate from -1 to 2. Clear? And then what does it mean to evaluate from -1 to 2? It means that I calculate 1/4 times 2 to the power of 4 minus 2 to the power of 4. And then here I write minus, and the same expression evaluated at -1. So it will be 1/4 minus 1 to the power of 4 minus -1 squared. Understood? Good? Now do this for root of x, please. Tell me what's the situation with root of x. All right, let's for root of x. 1 to 9 root of x. What's the situation, please? So what do we do, guys? We find the antiderivative of root of x, which is x to the 3/2 times 2/3. Do you agree? And then evaluate from 1 to 9. And what do we get? If we plug in 9, so it's 2/3. We can plug in 9. So that would be square root of 9. It's 3. 3 cubed is 27. So that would be 27. And then -1. So the answer is 26 times 2/3. So it's 26 times 2/3. Good? Can you do number C? Alrighty. Alrighty. So guys, what do we do here? We convert t to the 1/2 and distribute. So this is simply 4t to the 1/2 minus t to the power of 3/2. Do you agree? We don't want to we don't want to deal with the problem without distributing the root. It's too ugly. And so now what's the antiderivative? So then I go and the antiderivative is t to the 3/2 times 2/3 times 4 minus this would be t to the power of 5/2 2/5. Yes, and we evaluate that from 0 to 4. Now if you plug in 0, it's gone, so really just need to plug in 4. So plug in 4, and what do you get? So you get here 4 square root of 4 is 2. 2 cubed is 8, and then we have 8 times 8 is 64, so this is 64 over 3. Correct my arithmetic. Then here we take square root of 4, which is 2. 2 to the power of 5 is 32. 32 times 2 is 64. So it's minus 64 divided by 5. Have I calculated correctly, my friends? Yes? Maybe I haven't, I don't care. You have to calculate correctly. Yes? So guys, please calculate D quickly. All right, where are we? Guys, D, I'm not sure where we are looking at. D. Yes, so what is the answer? Let's see, so secant tangent theta. The antiderivative of secant tangent is tangent, yes? I mean, it's secant, my apologies. So it's secant of theta evaluated from 0 to pi over 4. Now, secant of pi over 4, as you correctly noticed, is root 2 minus secant of 0, which is 1, right? So you are absolutely right. Everyone that I've seen writing root 2 minus 1. Good? Clear, guys. Now E. Very quickly calculate E. All right, so we are doing this secant squared. Its antiderivative is tangent of t from 0 to pi over 4, what do we get? We get tangent of pi over 4 is 1 minus tangent of 0, which is 0. So the answer is 1. Absolutely right. Now F. F, guys, fast. Okay. All right, so how do we solve this situation, guys? Well, first of all, we observe this is integral from 1 to 2 of 1 over v plus 3v squared dv. Do you agree? I distributed the v as we did before, and that allows me to, so now what do I get here? Now I see that this is ln of v. I can place absolute value, but since it's between 1 and 2, absolute values won't do anything, plus v cubed. And I need to evaluate this from 1 to 2. So plugging 2, I get ln of 2 plus 8. And then I subtract, I plug in 1. So it would be ln of 1 plus 1. Yes? Now ln of 2 plus 8 is what I have here. Ln of 1 is 0. And so I subtract 1 and I get ln of 2 plus 7. The answer is ln 2 plus 7. Very good. All right, guys, one more. Let's do this one. 8 over 1 plus x squared. All right, and the answer is, guys, 8 over 1 plus x squared. The antiderivative is 8 tangent inverse x, evaluated from 1 over root 3 to root 3. Yes? And what do we get? This is 8 tangent inverse of root 3, guys. Do you know what it is? So you need a particular triangle. So the triangle would be pi over 6 and pi over 3, pi over 6. So then we have here root 3 over 2, 1/2, 1. So we know that tangent of pi over 3 is, so this would be pi over 3, because tangent of pi over 3 is root 3 over 2. And 1 over root 3, how do you get 1 over 3? Is this to that. So that would be pi minus pi over 6. You agree? So the answer is 8 pi over 6. You can simplify it further. Yes? You understood what I did, guys? The triangle. You need to know those triangles very well. So there is the triangle with pi over 3, pi over 6, and the triangle with pi over 4 and pi over 4. That's not too much to know. And here are a bunch of also elaborations. And this we will cover later. All right, guys, so this is the last thing in terms of calculation. I'm hoping to complete it today, maybe a little bit on Thursday, and then we spend the time on grueling and wonderful theory to understand what those things are and why are they meaningful, etc. So, guys, here is this thing. So we go back to that exercise. Again, it's called substitution rule, or U substitution, but what it is, it's reverse chain rule. Mainly, it's just a technique for reversing chain rule. So let's again train to reverse chain rule a bit more. Please place something in here and make the integral very easy. Very well. What do you place there? You place there a what? 3. What do you place here? What's the inner function? You place there what? You made a small mistake. Come on, guys. I want to see many answers. Not 4, not 3. I need to see tons of them. Yes, wonderful. 3. I want to see more answers. Where are those? All right. So we place a cosine. Do you see why cosine, guys? Because now it's perfect chain rule, and then the answer is very simply e to the sine x. You agree? Because I just need to focus on reversing the derivative of the outermost function then. I hope you will see that, and I hope you will not forget it. Right? Just think in reverse. And then the last thing that you have to cancel or undo is the derivative of the outer function. And that's pretty much all the effort in chain rule. Good? So it's this situation. So the answer is sine e to the sine x plus c. Do B. Three x squared. Very good. You see that x squared here. So you want to place here a 3x squared. What is the answer now? You all see why 3x squared, because you just recognize there was a derivative of outer function, and then there must come afterwards the derivative of inner function. If it were 3x squared, what's the answer? Amazing. Secant x cubed. Very good. Now I want you to tell me what to place here for C. Here it's ln x. What do I place here for the box? Very good. 1 over x. I hope you're not looking below my notes, guys, right? There is no reason to cheat me and make me feel happy, right? I mean, that means you understand it, right? So it's 1 over x. Now, what it means, guys, is that the derivative of the outer function is ln to the power of 1. What's the answer? Very good. 1/2 ln squared. So the answer is 1/2 ln x squared plus c. The outer function is not so easily seen because it's to the power 1, right? So it was to the power 2. Understood? Please help with D. What do you want to put in this box? All right. Yes, exactly. You want to place here, guys, 3v squared minus 4v plus 1. Do you agree? If you place it in the box, it makes the integral very simple. Could you tell me if that's what I place into this box? What would be the answer? Very good. It's ln of the same thing, right? So the answer is simply ln. You can place absolute value v cubed minus 2v squared plus v plus a constant. Place ln and afterwards absolute value because that allows antiderivative to work for negative values where this is negative. Good. And now please do E. Very good. So for E, you would like 2 pi x, and then tell me, please, what's the answer? If I place 2 pi x here, what will be the answer? The answer will be, if you place 2 pi, so it would be what? So antiderivative of that is sine of pi x squared evaluated from 1 to 2. That will be 0, as some of you wrote. Yes? You see why? Place 2, it's sine of pi times 4, and then if you place 1, it's sine times pi. It doesn't matter. So it's just 0 minus 0. Okay, last one, f. F. What do you place here? That's possible. So for f, guys, you should see there are two possibilities. One of them is I can write something like this integral 1 to 27 of 1 over x squared over 3 plus 1, and here I just take the derivative of that, so it will be 2/3 x to the power of minus 1/3 dx. It's one possibility, and another possibility is to do this. And then I look at it, and this would look like, so it's 1 over x to the 1/3 squared plus 1 times 1/3 x to the minus 2/3 dx. Yes? If I do this possibility, then the answer will be tangent inverse of x to the 1/3 evaluated from 1 to 27. Do you see that? So if I go with second option, you can go with first option, but I decided to use the second option. And then I have the cube root. It just looks nicer. You see, I figured tangent inverse will make it nicer numbers. So cube root of 27 is 3, so it's tangent inverse of 3. And minus, if you place 1, tangent inverse of 1. And at least one of them is very easy. So this is tangent inverse of 3. Tangent inverse of 1 is pi over 4. Right? So it's tangent inverse of 3 minus pi over 4. So I decided to go with second option. Good? So this is just that calculation that we carried through, guys. And this is a preparation to use substitution, which we are running out of time, and I'm not sure if I would be happy to hold you an extra hour or 2 or 3. I mean, but I do not know how happy you would be of it. Now, I hope you had a good weekend. Something pretty weird happened to me. I mean, my friend has located, and I thought it would be completely impossible, he located a video of me from childhood, right? And this was, well, I mean, you understand that it's a very rare event. Cameras were not around. And yes, I did not think one exists, but he found one. Well, yes, younger than I am now, so you can imagine that it was in biblical times. Usually people that see this video after 7 days, they are no more. So have a good one. Goodbye, guys. Take care. Study very hard. Watch those videos. There is going to be theory. Do you understand? I mean, right now it's boring. We're going to talk about the theory, and we will talk until the final. Sure.